Now we're entering the section where we're all talking about the heart. And the heart is the biggest muscle in the body, controls everything we do. It supplies blood throughout all of our muscles, organs, everything. Heart's good, we can't live without it. We love the heart. But essentially, first thing we want to understand is how blood flows through the heart, or how it gets from one side of the body to the other side of the body and gives all organs oxygen and makes them all happy. So here's a picture of the heart that I drew just now, but we'll make it a little more simple to understand it. And look at that picture, and we'll just draw a very simplified version of the hearts. And essentially, it's just a little square. That's really all the heart is a four-chambered square. It's the biggest muscle in the body. It acts as a double pump, where it takes deoxygenated blood and pumps it to the whole body, or makes it pick up oxygen and pumps it to the whole body, so the whole body gets blood. So really, it's just a pump. It's a four-chambered box. So whenever you're looking at the heart, always draw a four-chambered box. Now, each chamber has a different role. We have the upper chambers are called atrium. So we have the left atria and the right atria. The bottom chambers are called the ventricles. So we have the right ventricle and the left ventricle. And the reason we're going over the blood flow in the heart might not be tested on or be gone over, but the reason we're going over is because the electrical once you understand the blood flow, the electrical stimulation, cardiac output, stroke volume, VO2, Frank Starling mechanism, exercise, all this stuff will make sense when you understand the blood flow in the heart. So we're going to take a few seconds just to go over the simple blood flow. So since the heart is, or the cardiovascular system is what it's called, is a closed loop in the body, when what this means is any blood that the left ventricle pumps out returns to the right atrium. So it's not lost in the arteries. Once it goes to the arteries or veins, it doesn't leak into the body. Hopefully, in a healthy individual, it doesn't. But first we'll start in the right atrium, where the cycle is normally gone over, and when it enters the right atrium, it's deoxygenated, so all the oxygen already left and went to the organs. So now it's returning back to the heart to pick up more oxygen and pump back out. So returning to the right atrium, it returns via the superior vena cava and the inferior vena cava. And the superior vena cava is this little guy up here, bringing blood, or deoxygenated blood, everywhere from above the heart. And the inferior vena cava is bringing deoxygenated blood from below the heart. Now, these are the biggest veins in the body. Veins are anything that go towards the heart. So if a vessel is going towards the heart, it's always a vein. No exceptions. So you have all this deoxygenated blood, and it enters the right atrium. So you have all this blood in the right atrium. Now, its goal is to get to the left ventricle, and the left ventricle is in charge of pumping out the blood throughout the whole body. So now, in order to get to the left ventricle, it can't just do this and take a shortcut. Can't do that. It's not allowed. So it has to go down to the right ventricle. But separating the right atrium to the right ventricle is a little door. And this little door is important because the purpose of this, because when blood does fall into the right ventricle, nothing is stopping it from going backwards and going back into the right atrium. And this is called regurgitation. Now, this will happen in an unhealthy individual with an unhealthy heart, but in a healthy individual, blood will not flow backwards. So that's what this little door is for, and it's very important. And this door is called the tricuspid valve, which I guess we'll write it out because that might be important and worth knowing. So you have the tricuspid valve separating the right atrium and the right ventricle. Now, once you're in the right atrium, it's still deoxygenated. So now its next stop is the left atrium. But before it gets there, it has to pick up oxygen from somewhere. And the best place to get oxygen in the body, of course, is the lungs. So from the right atrium, it has to have a way to get to the lungs. And, well, you know, it does. So to get to the lungs, it goes through this artery. Now, it's called an artery because it's going away from the heart. It's not going towards the heart anymore. And this is called the pulmonary artery because it's going to the pulmonary circuit. Or it's a fancy word for lungs, just pulmonary. So now it picks up the oxygen. You have all this deoxygenated blood, whatever. It picks up oxygen, so now it's all happy. It has oxygen. So now it flows into the left atrium. And now it's red because it has oxygen. And since it's flowing towards the heart, what is it? It's a vein. Remember, veins always flow towards the heart. So this is called the pulmonary vein. So now we have all this oxygenated blood in the left atrium. But just like in the right atrium to the right ventricle, it has to flow down to the left ventricle. So it flows into the left ventricle. And just like this side of the heart, there's also another valve, so it doesn't flow backwards. And this valve, this one, is called the mitral valve. Now another word for both of these, the tricuspid, well, it's only called tricuspid, but the mitral valve is also called the bicuspid valve, in case he ever uses two different words of the same thing. Mitral means bicuspid. So now it's in the left ventricle. So now the left ventricle is very important. It's one of the strongest muscles in the body, or one of the strongest muscles in the body. So now, of course, this whole heart is a muscle, but now the left ventricle has the role of pumping the blood throughout the whole body. It's called the systemic circulation, or systemic meaning the whole system. So now it pumps all this blood out through another artery called the aorta, and this artery goes throughout the whole body. So it pumps all this blood out the aorta. That's definitely a word worth noting, aorta, throughout the whole body. And this is an artery because it's going away from the body. And then eventually goes throughout the whole body, goes to whatever organ, your arm, your foot, your leg, your toe, whatever the hell. Goes to everything, goes through capillaries. Say this is a capillary. And in the capillary we have gas exchange. So all that oxygen that was in the blood now flies, oh, that's not the right color, flies out of the blood. So now all the oxygen leaves the blood that's inside the artery and goes throughout the tissue, does its job, perfuses the tissue, whatever, keeps the tissue alive. So again, this was an artery going to capillaries, and now no oxygen is leaving the capillary, the artery, at any point during it. That is not happening. It only leaves at the capillaries. Once it gets to the capillary, now it's deoxygenated, of course. So it has to go get oxygenated again. So of course it goes through the inferior vena cava back to the heart, and the whole cycle continues. It repeats. Now this is just one little capillary. Now there's millions and millions of capillaries in the body because you have millions and millions of arteries. Blah blah. Just say if you take all the arteries out of someone's body, all the arteries and veins out of someone's body, and lay them end to end, it equals like 63,000 miles. So that means there's a lot of fucking arteries in the body. So that means there's a lot of capillaries. Now this is just one. Now this whole cycle from going the left atrium, the right atrium, right ventricle, getting oxygenated, going throughout whatever, this is all one heartbeat. So erase that. Now that whole thing was just one heartbeat. And we'll abbreviate heartbeat. Oh, that's heart rate. Damn it. So that whole thing we just went over is one heartbeat. And of course the heart beats it beats 1,000 times a day pretty much. So that cycle is continuously happening in the body. So now we can go back to now talk about electrical stimulation because it lines up perfectly with what we just talked about. Actually, let's go over electrical stimulation in another video so this video isn't too long because it's already airing on like 10 minutes. So essentially that was blood flow through the heart. So let's just quickly recap it. Because if you understand blood flow through the heart, it's very easy to understand electrical stimulation, cardiac output, VO2, Frank's line mechanism, essentially what happens to the heart with exercise and everything. And of course, what can happen to the heart, like during a heart attack, what actually is happening, what is a heart attack, all that stuff. So you have the blood enters here, in the right atrium, and goes down here, goes through the little valve, the tricuspid valve, goes out to the lungs, enters the right ventricle, goes down. This is the left atrium. But it goes down to the left ventricle and gets pumped out throughout the body. And the aorta goes throughout the body, goes to capillaries. Oxygen leaves leaves the blood stream. And it returns through the superior and inferior vena cava, the biggest veins in the body. So that's the simple blood flow through the heart. So now we'll go back to the beautiful hearts that I drew.